Okay, so mabalik tayo dun sa example. So, kanina pinakitaan ko kayo nitong given. So, you have ethylene or ethene plus hydrobromic acid, and then it reacted to form bromomethane. But then how can you actually come up, or how if we were to ask you to draw a probable and a reasonable reaction mechanism for this, how do you start? Paano niyo po ba yan naalamin? So, Tito, actually po, if yung prerequisites na binanggit ko sa inyo kanina, if you have an appreciation of the structure, of the right structures, of the octet rule, of bond polarity, of dipole moments, kahit po hindi nyo masyadong alam, or hindi nyo nabasa sa libro ano bang type ng reaction yun, you'll be able to figure out a way by which you can draw a reasonable reaction mechanism. And yung first step po typically dyan is you have to analyze the structures of your reactant. So dito po, we have to analyze the structure of ethene, and then we also have to analyze the structure of hydrobromic acid. And this is how we are going to do this. So this is the structure of ethene. So sinabi nga po kanina na Professor Dindi, there's a carbon-carbon double bond present in there. And ito po, ide-demo ko sa inyo. I need to be able to see myself as I do this. I'm just gonna move. Okay, my camera somewhere there. So ito po yung three-dimensional. It's a ball and stick representation of ethylene. So ito po, it's actually a planar molecule po where this is your carbon centers forming a carbon-carbon double bond. So yung una po ditong bond is the sigma bond, and then the other one is the pi bond. And then planar po, coplanar po with this bond are all the carbon-hydrogen bonds. And typically po, for most of the hydrocarbon transformations na tinuturo sa high school, no, these carbon-hydrogen bonds, unless in the presence of radicals, they don't usually react. Lalo-lalo na po sa alkenes. All of these vinylic carbon-hydrogen bonds are very strong bonds, so hindi po sila masyadong reactive. But then ang focus po natin ngayon is actually in this region. So this particular region has two bonds. So it has two pairs of electrons. So ilang electrons yun in total? It has 4 electrons around this region. So if you could imagine this po, itong gitna na part na to, this is electron-rich. Marami siyang electrons. And then one very important thing is that the pi bond is actually is relatively more reactive than your typical sigma bond. So it's the presence of the pi bond that's making this fairly reactive. So gaya nga na po na sinabi ko dito kanina, in-indicate ko na ito, this is a region that is fairly rich when it comes to electron density. So dito po, since this region is electron rich, you can actually call this region or the pi bond a nucleophilic area. Okay, so it's a nucleophilic part of your ethylene or your ethene molecule. Okay, now, mapunta naman tayo dun sa hydrobromic acid. So sabi ko nga sa inyo kanina, if you have a very good understanding of Lewis structures and bond polarity, malalaman nyo, how would these behave during a reaction? So hydrobromic acid here, as I was telling you, is a polar, as I mentioned before, is a polar compound. So why is it polar? Because bromine is more electronegative than hydrogen. So when they form a bond, what happens is that an electronegative atom tends to withdraw or tends to attract more of the electron towards it. So kahit po itong hydrogen-bromine bond dito ay single bond, majority po ng electron cloud dito ay napupunta or lumalapit sa bromine. And that results in a net dipole moment, making it a polar compound. So sabi natin, more of the electrons are attracted towards, attracted towards bromine. So therefore, yung bromine dito is partially negative. Pag sinabing partially negative, mas mataas yung electron density around it. Pagdating naman po sa hydrogen or the proton in this structure, partially positive siya. So kasi naaagawan siya ng electron eh. Medyo may pagkaswapang po itong bromine. So in this case, partially positive yung hydrogen. And 'di ba sinabi kanina na Professor Dindi that, regions in a molecule that is partially positive, that is electron poor, and therefore you can call it an electrophilic center, an electrophile. Yung region naman that is electron rich, which is bromine in this case, is nucleophilic. So, and then Yun naman pong pi band or yung region dito that is very rich in electrons is also what we call a nucleophile. So kapag ganito na po yung inyong dissection ng structures of your reactant, malalaman nyo na alin ba dito yung posibleng mag-react. So therefore, dito kung iisipin nyo po, bromine, you can call it nucleophilic. Pero ang tanong po, between these two species, meron bang region dito sa ethylene na pwede siyang i-attack? Parang wala naman. Kasi diba sabi ko sa inyo, these carbon-hydrogen bonds are unreactive. So therefore, walang region na pwedeng i-attack itong bromine dito sa inyong ethene. But then the other way around, your electron-rich area here in ethylene can attack the electrophilic center of hydrogen and hydrobromic acid. And that is actually how you map out the first step in a reaction mechanism. Ano ba yung mga parts? Ano ba yung moieties in your molecules na yung charges are yung nucleophilicity and electrophilicity are actually matching. So essentially po dito, yung konsepto lang ng opposite attracts. So dito, ang first step is that your pi bond or your electron-rich center between those two carbons in ethene will actually attack your electrophilic center. And why is that? It's because this is electron-rich, this is electron-poor, so partially positive, partially negative, opposites attract. So yan na nga po yung sinasabi natin, diba? Sa love life, yung good girls laging gusto ang bad boys. Parang ganon yung gagawin yung analogy dyan. So what happens here is that, ito po, I'm gonna be using a model here. If this is the pi bond, what happens is that your ethene molecule will actually use it to abstract or to attack your, to abstract your electrophilic center here, which is your hydrogen. So parang yung pong first step po sa chemical reaction is such that your molecules should actually orient themselves in a way that's making that will make it possible for them to bond. So dapat po meron rin silang specific distance in space and orientation for the reaction to happen. So dapat po nagdidikit po yung mga yan. So kumbaga po sa bonding ng mga pagkakabarkada, mahirap po makipag-bonding kapag ang inyo pong kabarkada ay nasa malayo. So kailangan po didikit yan. So what happens is that yung initial orientations in space po niyan is that your proton should be close enough to your pi bond. And so what happens is ito po yung transition state na tinatawag natin. So dumidikit yung hydrobromic acid dun sa inyong ethylene molecule, and in the process, your ethylene molecule is actually using its pi bond to attract or to abstract your hydrogen here. And then so what happens afterwards is that yung electron pair dito sa carbon-carbon double bond is being used to form a bond with hydrogen here. And in the process, kung mapapansin niyo po, nagfo-form ng bond between your alkene and your hydrogen with hydrobromic acid. And so ito po yung tinatawag natin na hypervalent proton or hydrogen. Sinabi natin hypervalent kasi it is actually getting surrounded, at least at this point, by number of electrons that's beyond what it can accommodate. Kasi ano nga po ang ating rule when it comes to yung bonding with hydrogen? A hydrogen atom can only has a 1s orbital, and that 1s orbital can only accommodate 2 electrons. So kapag po dinonate or kapag inattack ng inyong ethylene molecule yung inyong proton dito, therefore nagdodonate pa siya ng electron pair. Meron na siyang electron pair dito, so magiging 4 na yung electrons around it. So that's what you call a hypervalent atom. And since lumalagpas na siya dun sa kanyang maximum number of electrons that it can accommodate, what happens is that kapag nag-form na siya ng bond with, saan nakikisama yung model ko, kapag nag-form na siya ng bond with your ethylene, like this, what happens is that it also breaks the hydrogen breaks its bond with bromine. So ito na po yung mangyayari dyan. Yung next step dyan is that bond between hydrogen and bromine will actually break. So in the process, the electron pair that was initially used to form a covalent bond with hydrogen ends up being taken away by bromine. So ganyan po yung nangyayari dyan. So ito na yung resulting species nyo dyan. So yung hindi po stable ang hypervalent hydrogen, therefore it has to break a bond. It has to let go of something. So yun po. And so what you end up with is this structure. So you have your hydrogen atom from bromine attaching to one of the carbon atoms. And in the process, medyo nakakalungkot po para dun sa pangalawang carbon, kulang siya. So it only has 3 groups around it. So 3 bonds around it. So therefore, it only has 6 electrons around it. Ilan po ba ang kailangang electrons ng isang carbon atom for it to be stable? It has to have a total of 8 electrons. Kaya nga po, octet rule. And this particular electron deficient carbon species is what we call a carbocation. So it is a positively charged carbon center. So yun po, papakatandaan niyo po yan. Yun yung sinasabi ko kanina na when it comes to polar additions or when it comes to heterolytic bond cleavages, usually it results in the formation of species that are actually charged species. So positively charged carbon atom or carbon center and then a negatively charged bromine center. Okay, so ano po ba nangyayari dyan? So one very important thing that you have to keep in mind is that again, since the carbon, and I cannot emphasize this enough, since this carbon only has 6 electrons around it, it's unstable. So, kumbaga sa love life, ito po siya yung naiwan. Siya yung naiwan sa relationship. So, siya yung nakulangan sa sarili. So, and then ito naman pong si bromine, tinangay niya lahat. So, siya yung medyo may mga sobra naman siyang daladala. Okay. And so, as I've mentioned, carbocation, positively charged carbon, electron deficient, it is unstable. So, therefore, so sabi nga natin, unstable siya. Therefore, it's very active. Hindi siya kalmado. So paano ba siya makakalma? So it can only be stabilized if it will get what? An extra pair of electrons to complete its octet. So what happens during this reaction is that since the bromide ion is just lingering around, what it's gonna do is that it's gonna use one of its electron pairs to attack this electrophilic carbon center. So in the process po, kumbaga sa nag-break, nagbalikan din naman po yan. So ang nangyari po, hindi pa rin nakipagbalikan, nag-form siya ng bond dun sa carbon atom. So iba na yung kapartner niya. Nakahanap na siya ng kapalit. So yun po, that's the process by which you actually stabilize that carbocation. You need a nucleophile to donate an extra pair of electrons to form your ultimate product, which is bromoethane. So yan po yung tinatawag natin na organic reaction mechanisms and then if you're actually gonna examine the net reaction po you started with ethene and hydrobromic acid. So what happens here for ethene during this reaction is that the pi bond was broken. The pi bond was broken because the electron pair and that pi bond was used to form a bond with your proton, and in the process your HBr bond is broken, and then ultimately the net effect is that you formed a carbon hydrogen bond and you also formed a carbon bromine bond. So that is what we call a polar addition across an alkene or a carbon-carbon double bond. Okay, so medyo madali lang po siya, hindi niyo siya talaga kailangang memoryahan step by step ba niyan. Ganyan. Kailangan niyo lang na-appreciate, okay, octet rule, right structures, polarity, charges, yun po yung mga bagay na basic knowledge that you will learn from high school. So ito po yung sinasabi ko na kapag medyo hindi solid yung appreciation ng mga bata sa basic concepts na yun, pagdating nila ng college, hindi nila masyado itong ma-appreciate kasi hindi nila masyado nare-retain po yung foundation knowledge. So ganito ko po ito in-approach nung ako po yung nasa undergrad pa sa UP, and it actually worked. You'll be able to ace all of your exams when it comes to organic reaction mechanisms kung solid ang grasp of Lewis structures, polarity, and electronegativity. So mahalaga po 'yun. And ang maganda po kasi dito is that kahit po palakihin nyo yung alkyl chain, pag alam nyo po yung polar groups lang yung magre-react, hindi kayo malilito kasi alam nyo ito lang yung reactive na part kasi yung iba naman hindi naman sila nagpa-participate. Yun po yung importance of actually making sure that you have a very great understanding of all of these steps. Okay? And then yung i-introduce lang po namin sa inyo kanina is the concept of transition state, yung orientation in space ng ating mga chemical species for them to react. Kasi kailangan niya po yun. Kailangan nagdidikit for your chemical bonds to form or to break. And then yung concept of an intermediate. So yung concept of an intermediate is actually when I showed you yung carbocation formation. And typically, these types of intermediates form whenever a particular reaction requires more than one step. So kung multiple steps po involved for you to get to the right structure or to the structure of your product, usually there is a chemical or a reactive intermediate involved.